Renewable energy resources, some decreasing costs, and increased competition in the battery storage space have made renewables much sought after. Last year, despite supply chain challenges, increased shipping costs, and rising prices for key goods, capacity installations were at an all-time high. Wind and solar capacity additions were up, and many states and utilities set clean energy goals to increase renewable portfolio standards. Coupled with the electrification taking place in the automotive space and the subsequent focus on charging capabilities, the world is focused heavily on green across the board. Renewable energy and electric vehicles are making strides in the technology realm. As these technologies become more accepted and adaptation takes place, it's critical for engineers to understand the power management solutions available and requirements needed to develop efficient products. We're here today with Peter Victoria, Applications Engineer at Recon Power, and Billy Seville, Regional Power System Sales Engineer with Sager Electronics, to talk more about power management for green and EVs. So thank you both for joining us today. We appreciate your time.
Yep, thank you for having us.
All right, so why don't we kick off by examining the current state of renewable energy? Are there any current power supply trends taking hold as we focus more on renewables these days?
So I think one of the big things is finding a complete solution that helps engineers, integrate something into their design really quickly, where they don't need to really be focusing on any of the design work. Very plug and play. In addition to that, I think obviously people are always looking for smaller footprints and higher efficiencies and higher temperature ratings as well.
So what are some of the different energy generation types?
So I think a couple of the big ones that we see for our company are both solar and wind. And I can touch on solar for a little bit.
Sure.
Okay, great. So one of the main ideas of getting solar power to be more useful is converting it from DC to AC. And to do this, you need an inverter, which basically does exactly what I just said. So Recon actually has a full line of power supplies that are dedicated to work with inverters and hold all the correct specs and make it very easy for engineers to implement them into their topologies.
And for wind, what's interesting is that you actually are creating, it's a generator similar to like a generator for the Hoover Dam, where, as water comes in, it turns a turbine and it creates AC, and then you have to figure out how to manage that to the grid. And there's a lot of interesting technology that Recon has in order to either convert it to DC for battery storage, do the conversion from AC to AC. They have some gate drivers in order to control that. So it's two separate type of energy types that require several type of solutions. And as Peter had mentioned, efficiency, size, ease of use, possibly not having to go through certifications such as UL and EMC type of testing is a high on the list of customers.
Yeah, and kind of going back to what you just said about the gate drivers and how customers will use that. So basically, this ties into a lot of different technologies, a lot of different semiconductors, such as IGBTs, silicon carbide, all those kind of FETs. So that's what engineers are using to basically take the DC power generated by solar panels and then put it back into the grid. So yeah, we have a wide range of products, all with the different correct gate voltages to ensure that those are all switching properly. It's a very precise switch that they need. So a lot of our parts also offer low isolation capacitance, which essentially just means that the customer is able to switch the part more precisely and get better efficiency going from solar to the grid. So yeah, wide range of products there.
I think you're talking a little bit about that transition, right, from renewables to the grid. But, are there any challenges that still exist? Even though you're talking about some of the solutions you have, I'm sure that we're still up against some challenges, right?
Always. One of the things is trying to implement the new technologies that are coming out. So, we're having a renaissance of new switching technologies, MOSFETs, transistors, which used to be MOSFETs and IGBT centric. Now we're switching over to what's called GaN and silicon carbide. And those are much more efficient, operate at higher voltages. They have faster switching speeds, which allows for smaller magnetics and components. There's a whole art form versus when you think of the old wall wart used to have 30 years ago, how big and hot that would get for getting 1 watt. Now everything is shrunk down based upon these technologies. So that is something that is, everybody is concerned with. PFC as well, which is power factor correction, in order for make sure that the voltage and the current are in sync in order to be more efficient. Once again, to save power and save money.
Now, we talked a little bit about gate drivers, right? What are some of the key specs that engineers are looking for in these gate drivers?
Yeah, so like I said, there's a few different types of material that they'll use. So whether it's IGBT, SiC, or GaN, each of these works a little bit differently. They all require different voltages to switch on and off. So for example, IGBT is plus 15 volts for the on state, and then usually minus 9 volts for the off state. It's a little different for every manufacturer. So customers, need those two voltages, and in the past, getting those two voltages meant using two modular power supplies, like stuff we use, or they would have to build their own circuit basically and figure out how to get those two voltages. But with our products, you actually get both those asymmetric voltages, so the plus 15 and the minus 9, in just one part. So that helps them out a lot. Also shrinks the footprint quite a bit. The other side of that is getting the correct isolation. So making sure that the input side and the output side, so essentially your input would be your control system. The output would be, the output would be working with these high voltages. And it's important to protect the control side from those high voltages. So customers also need reliable and good isolation to make sure that their systems are going to be reliable for many, many years.
Yeah. In particular, like for industrial, people are happy with 1.5 kilovolts of isolation, but in the medical world, it's up to 4 kilovolts.
Right.
With IEC 60601, which is a standard for medical parts. So Recon can has products for both those.
Yeah, for us on the gate driver side, it's very typical to see 5 kilovolts and even higher, and that covers basic isolation, and we even have some parts that go up to reinforced, which is good for the medical side of things, like Billy alluded to.
I'm hearing flexibility here. I'm just wondering, do renewable energy sources, do they affect a power system stability?
Oh, excellent question. So when you have solar and or wind, the voltages and currents that are coming in, they could be in a very heavy wind. Think about a turbine, right? How they have to, you don't want to overdrive some of the technology. In fact, they actually have the capabilities of changing the fins on the turbines so that it doesn't destroy it, which we've seen videos of that, and then also to provide the proper maximum power to the circuit. So the same goes to solar using something called MPPT, which is basically the curve of maximum amount of solar to deliver to the actual, the end user without overriding and balancing it out very nicely. So that flexibility is key. It's important to have a big range of voltages, currents, powers, and isolation, as Peter mentioned, to compensate for worst case scenario.
You mentioned quite a few technologies there, like liquid cooling, heat sinks, things like that. Are there certain ones that you guys usually recommend in certain ranges, right? Is it?
So I could give you a couple of examples. Great question, Brian. What's interesting is that some people don't want fans because fans might fail, and then when it fails, it overheats. Other people want fans because they're inexpensive relative to liquid cooling, which could be water or some type of antifreeze, depending on what environment they have. So our challenge at Sager, and we have a dedicated a thermal expert. I think he was on a previous podcast, Vineet, and he's fantastic. We have a power supply. A power solution center down in Carrollton, Texas, and we have the battery solution center in Lisle, Illinois. And in conjunction, we're able to provide all that, working with Recon and our thermal suppliers and their technologies to maximize the solution that's cost effective or what's important to the customer, the end supplier.
Yeah, and another thing that might be overlooked, or something that Recon and Sager can help with, is the EMC design and performance. So EMC stands for electromagnetic compatibility. So it's essentially looking at the EMI noise that's either coming from your product or that other things, other noise sources can be hitting the product and jamming it up. So that's often super tricky to work with. It's black magic. I don't really understand it, but we have a whole team at our headquarters who's all they do is EMI work. So we optimize that for our products. And then if customers are having issues with their application, because sometimes the board layout where they place the parts, that can all impact it as well. So that's a service we offer. We can actually take the board back and take a look at it for them, make suggestions and have it so they can go through certification and pass the first time.
All right. So it sounds like it makes sense then to talk about other green and environmentally friendly technologies, like electric vehicles. Those are so popular these days. How many different EV charging applications are there right now? I'd like to actually break it down for the audience. Can we talk about them briefly?
Yeah, there's quite a bit. People are often focused on a lot of the big companies like, Tesla or Rivian or even Ford coming out with their new stuff. But there's a lot of smaller companies and, more niche kind of products that also are going to be switching to EVs. So anything off highway, so such as material handlings like a forklift, a cherry pick, even a snow plow, a riding lawnmower, people movers like wheelchairs, golf carts, any kind of airport kind of transportation equipment, that's going to be shifted to EVs as well. So yeah, there's a lot of different applications and technologies.
Now, is there a need for low power AC/DC and DC/DC converters in EV chargers?
Yeah, absolutely. So a lot of these also are, connected to the internet these days or require some sort of power monitoring, making sure that the battery levels are not being overcharged, making sure that they're getting the right amount of current, sending data back and forth between the cloud, looking at energy levels, and people can do big data stuff there. So a lot of that low power control equipment will require a reliable AC to DC or DC to DC converter, because basically these guys are accessing their power from the grid. So if you have like a 5-watt load, you can have a AC to DC converter, low power, and just take power directly from that, and good for all that different control equipment.
Yeah, the IoT really almost requires some type of recharging because a lot of it's run off lithium batteries. Right. The RV world also uses portable solar panels, and backpackers use it to charge. So there's a lot of interesting technologies being used. I've seen them implemented in backpacks to charge your iPod while you're walking in the sun or you're hiking. So I've seen it range down to very microwatt energy harvesting all the way up to hundreds of kilowatts of megawatts of power for solar farms. So yeah, the range is there from small to big on AC/DC and DC/DC conversion.
A lot of people are saying, EV charging times are too long. This is important to think about as they're becoming more widely adapted. Are there any solutions to this long charging time problem?
Absolutely. What's interesting is if you think about your home, you have a 120 volts outlet, and basically it's good for about 1800 watts, what your hairdryer maximizes at. However, you start going up in higher voltage and bigger connectors. Tesla has 40 and 100 kilowatt superchargers, up to 480 volts, but they're capable of managing that. So as we talked about early in the flexibility of trying to do designs, you can't try to run a lot of power through your normal outlet because it would blow the circuit breaker or possibly cause a fire. So that's where the balance kind of comes in. The superchargers can charge the Tesla, recharge to 50% in 15 minutes. I'm not sure about the exact numbers, but it takes you overnight at home to charge with just a standard outlet. So that's always the balance is simplicity, ease of use. You obviously can't, construct a Tesla supercharger in your garage unless you're actually probably Elon Musk.
Right. So sometimes power supplies are more of an afterthought in the design, such as cooling, things like that. What are some of the things that need to be thought about? What are some of those factors that engineers need to think about?
Is that true too? That's something that we've thought, it's almost like, oh, how do we power this thing after we've designed it, right? Is that common?
Yeah,
absolutely.
Yeah, we definitely see that a lot. A lot of customers, especially now with component shortages, are really, looking really hard for power supplies. But
Right.
yeah, it's not really, it's not really we call it the sexy part of the design, right? So yeah, like you said, people are trying to get their product to work, and then once it's all done, it's like, okay, well now we need to get a power supply on this thing.
Now that's what's kind of nice about Sager is Recon. If Recon makes a 95% efficient DC-DC or AC-DC and it's 100 watts, that means that 5 watts is generated in heat. Now, sometimes it just dissipates on its own. However, Sager works with some of our key thermal companies in order to provide fan, heat sinks, liquid cooling solutions for high-powered lasers. I was just working on one for 3,500 watts and for a power supply, and even though it's very efficient, they still need to get that heat out. So between fans, heat sinks, and all of our Sager's suppliers, we can work with Recon in order to, kind of merge the two for extremely intense power designs.
Right. So when it comes to power, you guys mentioned some of the things like GaN and IGBTs, but how do you actually integrate? How is this actually being integrated into the designs for these applications? And what do users and engineers need to know?
Well, what's interesting about so IGBTs, MOSFETs, GaNs, and SiC, silicon carbide, are all switches, and what they're basically used for is to switch power in order to direct it into the proper circuitry at the maximum level of efficiency and speed. It's all balanced a lot of times of efficiency, size, and it's always, you could always, there's trade-offs for anything. And that's what engineers always have to do. Like, hey, you could have the best, the fastest, the most efficient, just like a car, but you're going to pay the price of a Ferrari. You may want something extremely efficient like a Prius. Well, it's not going to be able to tow an RV behind it. Think the same thing for electrical from a analogous type of viewpoint, is that is the challenge every engineer does, especially in the EV space.
So it's almost like
the green space.
So it's almost like you need to pick the correct technology or switch, right, for your application.
I was just thinking about something that we didn't discuss already. Where is Recon? Like, where are we going? Green is such a buzzword, and EVs are so popular, and we're talking about charging. Like, what's next for Recon then? Where do you go from here in terms of these technologies?
Yeah, so what's next for us is going to be actually we're going to be on EVs, on these not Tesla, not those guys, but on the golf carts, on the airport equipment. So we actually have a line of new e-mobility products that are DC to DC converters, and they're designed to take the voltage right off these batteries that are going to be equipped on these EVs and power different systems within the car. So whether that's, the entertainment system or the braking system or, monitoring the battery level, all those kind of things. We have these new products that are going to be very easy to design with, all plug and play, carry all the correct certifications. And we're just hoping it makes a lot of people's lives a lot easier when they're designing their EVs.
Actually, Billy, how does that pair up with some of the stuff you hear out there in the field from the engineers then? Are they prepared for what's next? What are you hearing out there?
It's definitely a new technology that engineers are excited to work on. They're not quite as familiar with possibly the how to get from, cradle to grave, as they say. But I think, as Peter mentioned, it's a lot easier when someone provides a main building block for you in order to achieve your goal versus having to do it possibly discreetly. So Recon's got a lot of great products that are already certified, and we work with our like I said, power supply system, and we can put that in together in conjunction with thermals, fans, and whatever it might be, in order to help the engineer, achieve their goals. So it's an exciting technology. It's bouncing all over the place, and it's popping up in unique places that is catching us off guard. But as the reason that Sager has power supply engineer or power systems engineers like myself is that they want to be able to be flexible in order to help the customers and pull everybody together, Recon, and in order to provide the solution for them, all the way down to their production.
All right, Brian, is there anything else you want to ask? Yeah.
The only other thing, I don't know if you guys want to, I mean, the only other question I may ask is, we mentioned such a diversity of products, everything from, industrial machinery to, a backpack with a solar panel on it, right? I mean, how wide is this, right? Is all this going to be in everything, right? We're going to move away and everything is going to be, charged by these type of, solar or wind or any of these other sort of renewable energies?
So what's interesting about renewable energy is that it's not always sunny, and it's not always wind blowing. So
Right.
the how you pull that together is by energy storage, which is where the lithium battery banks come in. Lithium is lead acid is a very inexpensive, reliable source that people have used, but lithium has got great power density, better recharge capabilities. It's lighter, it's more flexible to some extent, and it's really important to merge those technologies. If you have solar and wind, but you can't rely exactly if it's going to be sunny, cloudy, windy, you have to figure out how to store that and then reuse that and invert that. Or convert that to DC or AC.
Mhm.
And that is the whole challenge for every engineer, whether it be running an IoT, a solar farm, the backpack with the solar charger. There's some fantastic, we actually had a company here in Cleveland that was doing, as you moved, it would create some current and charge your iPod or whatever you might have.
Right.
And so there's the whole challenge is if it's something isn't reliable, then you have to try to figure out how to adapt to either efficient conversion and or storage.
All right, guys. Thank you again, Billy and Peter, for joining us. If you could just let everybody know where they can learn more about Recon and Sager. Peter, where can we go on Recon?
Yeah, so you can go just to recom-powered.com, and there you can find all of our products as well as a bunch of good resources and emails to contact other engineers like me or our salespeople. So we are a global company, so we're everywhere. So we're here to support anyone who needs us.
And Billy?
You can go to sager.com or power.sager.com if you're looking particularly for power solutions. We're underneath the Berkshire Hathaway umbrella as well as under TTI, and we have $400 million in sales and $150 million in power alone, and we stock $100 million in power solutions, and we have power supply experts across the nation like myself to help you out in custom solutions. Glad to help.
Thank you very much for
Awesome. Thanks
joining us
so much,
today.
guys.
Thank you.
Yeah, thank you.